way to predict the direction of the current in this case, right? Let's be a positive charge on that wire. Are you picturing this? Okay, we are now a positive charge. Okay, which way is the positive charge moving?
That way.
That way. Which way is the magnetic field? That way. Which way is the force on that charge? Up this wire. Yes? The positive charges are going to migrate up the wire. Won't that make it go anti-clockwise? Yeah, the laws, they work together. They're like the teeth, well machined. Yes, there we go. Now, let's remove the U-shaped piece of wire. This part here. Let's remove that part and just have a wire moving through a magnetic field. Are you picturing this? Well, that's interesting, isn't it? Because doesn't that mean that the positive charge will still migrate to the top of the wire? Yes. So that means that there's an EMF even if there's not a loop on a piece of wire. Yeah? Bossi talked about this last year. He says that when they were moving pieces of metal, like aluminum dewars, into magnetic fields, it was really, really hard to move them into the magnetic field. Why? Well, because there was an induced EMF in that piece of aluminum, right? He'd move it in there and be like, oh, and you like have to push it. You could feel the resistance. You'd be like pushing, just there it is in air, right? You're pushing it into the magnetic field. You could feel it. To tip it over, to let the liquid nitrogen pour into the thing, all you'd do is you'd take the thing and you'd start to tip it, and it wouldn't want to tip. You'd be moving it, and it'd be like starting to tip, right? Can you imagine that? It'd be like it's in a molasses. Are you picturing this, right? And so all he'd do is he'd tip it to the side so it started to pour, and then you just walk away. And gravity would slowly move it like that, and it would pour, and it would just auto-pour. Isn't that cool? Right? Because of the idea that you induce currents in any piece of metal that's moving, which is sort of an interesting thing. Okay, now, how do you calculate this thing? Well, here's the trick on these problems. We need to do something. B doesn't change, it's the area that changes. So here's our change in area. Let's take the time to be 1 second. Right, so t is 1 second. What is our change in position in 1 second? 2 meters, right? So our change in area is 1.5 by 2. 3 square meters, yes? Yeah? So in 1 second, this thing's going to go 2 meters this way. We now have something that is 1.5 meters this way, 2 meters this way. Yeah? Okay? So your change in area is 1.5 by 2. Okay? The magnetic field is this, and then it's just NBA over T. So calculate that. N is 1, yeah. N's 1 a lot. So are you going to be like a professional photographer?
Even though I get paid for it right now, it's just a hobby.
You're getting paid for it?
Yeah, I take photographs for the newspaper.
And they pay you at the newspaper?
Yeah.
You guys listening to that? That's cool. He's in Bozeman.
Are you a Bobcat? Yep.
Yeah, and don't get it wrong. Don't say he's from Missoula because he gets kind of... That's right.
These are nasty.
Are they? Yeah, they put their pants on 2 legs at a time. Yes.
Could you explain
Yes.
one more time how we know which direction is
Yes.
going?
Yeah, just a sec. That's right. Yeah, so the direction is... That's right. It's opposing it, so we're getting more into the page, so we make out of the page. Yeah? Yeah. Doesn't matter because electrons, everything's minus, so it all works, right? Huh? Yeah. 9.6 volts, that's correct, yeah. What? Physics 2? Right, so it's 1 times, and then the change in area is 1.5 by, right? Because it's 2 meters per second, right? Yeah? Yeah? So that's a second, that's supposed to be an S. Are we good with that? Does everybody get 9.6?
Yes.
No, wait. Are we good now?
Yeah. I'm confused about the area. Oh my God.
All right, are we ready for another one? Nutter, nutter, butter. So let's do one with an angle. Let's do one with an angle.
No!
So here we have, and I hope you appreciate this. This is just an amazing thing.
Oh my God.
Just call me Murray. Yeah. Isn't that amazing? Look at that. Well, I don't know if I realized it last year. This year I'm like,
It is perfect.
it's total coincidence, but well, thank you. Thank you. It's a total coincidence. I don't want to elevate my already near godlike status to anything that would be inappropriate, Okay. Now, take a look at this. Okay, leave him alone. Okay, take a look at this. You weren't digging at him, though. You were digging at me. So. Class. Okay, so what we're doing now is we are taking this guy and we're changing the angle and we're making this be a 57-degree angle, like that. Now, first off, do you see that the amount of light shining through the loop becomes a lot less? Okay, so that's why our flux is becoming less. Okay, so what's changing here?
The angle.
The angle is changing, yes? Okay, so in this case we are changing the angle. And now the question is, before we go and calculate it, the question is 57 degrees the right angle? Because sometimes the angle they give you is not the right angle. So here, let's take a look at this. Right now the angle is 0. Our initial angle is 0, yes? And now we tip it up like this, and what is that angle? Well, one of these angles here is 57. And one of them is its complement, right? 33 degrees, right? I think this is the 57-degree angle, isn't it? I mean, we could prove that rigorously and trigonometrically. So I think 57 is the correct angle. It is the angle. We want to always use the angle between B and A. Yeah? Why am I holding the A vector perpendicular to the area? Because that's what it does. That's what the area does, right? So here, 57 is what we do. Now be careful. Be careful, because when you do this, when you're doing this thing, what's up, Dan? I got him. You got to come up with an answer. I need an answer. Daniel didn't answer. He's gone. He always goes, what's up? And I go, physics, right? So I beat him to it. I clearly did beat him, didn't I? Yeah. So I don't know. Okay, so. No, because maybe, yeah. Maybe it was, yeah. Okay, so anyway, it's going to be cos minus cos. This is very important. Okay, don't you have to do cos minus cos? Yeah. And isn't one of them cos 0? And isn't one of them cos 57? Yeah. So be careful. And also, yeah, be in degrees. Degrees are going to be your key to happiness.
So it's not 80. What in math class?
N is still 1.
Okay. That is definitely not what I got. I don't know if that was necessary.
Final. You remember this?
Yeah.
Yeah.
I missed one that was this easy.
Do I?
I missed one when you explained it before.
Yeah. You missed when I explained it?
Yeah.
Oh, okay.
No, I missed.
The class.
Yeah.
Oh, you missed me explaining it.
The only problem is that I get 257,000. He was literally the worst. 2,535,000. I think on this planet.
The what?
I think he was literally the worst physics teacher.
Could have been. Yeah, you got it. Are you using 82 meters?
Yeah.
That's a big loop of wire.
Oh.
There's a factor of 10,000, right?
There's my problem.
Adrian, come here.
Yeah. That's your
Wait, this is Adrian Lucas.
Yeah. A lot of these people do.
You're going to be famous now.
College is great. College is great. Yeah. There we go. Now I got you got a nice.
Have you gone hiking?
Yeah. I've been to Yellowstone twice.
Okay. Have you gone up into the Spanish Peaks and stuff?
No.
Very pretty.
Yeah.
Recommend. I could show you a hike if I still remember it. That's right. Probably no bad hikes, but there you go.
Those are bad hikes.
There you go. Let's not worry about the direction. We haven't talked about the direction. We'll do that all together.
Do you mean like the negative sign over there?
Yeah, don't put a minus sign on it. You got it. You got it. Yeah, I did. I used to lead, or I led one hiking trip up in the Spanish Peaks. We did like a reverse thing where